All right, here are some examples of differentiating with composite functions using exponential functions. So let's start with this one, y equals 2 to the 3x squared minus 1. So let's first locate our inner function. So let's remember how to do this. If you are going to evaluate y equals 2 to the 3x squared minus 1, and you're going to put in an x, like maybe say we'll put in x equals 5. Probably the first thing you're going to do is figure out what 3 times 5 squared minus 1 is. By the way, that's 74. And then after you figure out it's 74, then you're going to do 2 raised to the 74th power. So whenever you're trying to figure out what your inner function is, it's always the one that you do first. You're probably going to figure out what 3x squared minus 1 is first, and that is your inner function. So our inner function is 3x squared minus 1, and that's what we call u. To figure out what our outer function is, we start with the definition. Y equals 2 to the 3x squared minus 1. And then everywhere, instead of writing 3x squared minus 1, we're instead going to write u. So we get 2 to the u. And that's our outer function. Y equals 2 to the u. Okay. Our next step is going to be to compute du dx and dy du in order to use the chain rule. Okay. So du dx is the derivative of the inner function u with respect to x, which is 6x, and dy du is the derivative of 2 to the u with respect to u, which is 2 to the u times the natural log of 2. So now we'll substitute in dy du. So we get 2 to the u, natural log of 2, times du dx. And now at this point, we don't want u's in our answer, so we substitute in u. Instead of u, we're going to write 3x squared minus 1. And instead of du dx, we're going to write 6x. So we get 2 to the 3x squared minus 1 times the natural log of 2 times 6x. And that's our final answer. Let's do another example. This is a particularly important class of examples that you'll see a lot of, and it's one that people get tripped up on. So let's differentiate y equals e to the tangent of x with respect to x. So remember, what is your inner function? That's step number 1. Try to see if you can do this on your own without me, and then play through the video and see if you have the answer correct. So our inner function is tangent of x, and du dx in this case is secant squared x. And y equals tangent of x, that's our e to the tangent of x, that's our original function. We're trying to figure out our outer function, so we get y equals e to the u. And we need to compute dy du, which is e to the u. The derivative of e to the u with respect to u is e to the u. So if I want dy dx, the derivative of our original function with respect to x, I need to compute dy du times du dx. I need to do this in 2 stages since this is a composition of functions. So let's substitute in dy du. We get e to the u times du dx. And now we want to get rid of all those u's. We don't want our answer to have any u's in it. So we get e to the tangent x times secant squared x. And that's our answer. Remember, secant is this function. It's a trigonometric function that we didn't talk about, but its definition is secant of x is equal to 1 over cosine of x.